This is a Raspberry Pi hosting an open wireless network named Dropbox, which redirects requests from connected devices to this page on its Apache server, which uses PHP to process requests and interact with the MySQL database behind it so visitors can upload files, pin messages to the message board, and leave a signature containing their name, a message, and a picture if they choose. There's a password-protected control panel for managing user-submitted content and an RGB LED that glows every time a file is uploaded. It's super simple. I'm going to walk through the process of building it step by step. You'll need a Raspberry Pi, its power supply, a computer, Ethernet access to a network connected to the internet, a micro SD card, means of connecting it to the computer, software for imaging Raspbian onto that micro SD card and making SSH connections. That'd be Rufus and PuTTY if you're on Windows. Means of determining the Raspberry Pi's IP address on the network, the MISTINC Dropbox files, and optionally an RGB LED, 3 resistors, wire PCB, and the tools for assembling the circuit. So that's solder, a soldering iron, wire cutters, and all that. First step is the operating system. Image Raspbian onto the micro SD with the computer. I use Rufus, like this. Once that's finished, open the boot partition and create a blank file titled SSH, which enables SSH connections. Plug the micro SD into the Raspberry Pi and connect it to the network using an Ethernet cable and not Wi-Fi. Determine its IP address and SSH into it with a computer, which looks like this on PuTTY in Windows. Use this command to update the software and this command to install the necessary packages for this build. This may take a long time and there are a few prompts in the process that you have to click through for it to finish. Second is a wireless network. Stop these services, open this file, and add these lines to the bottom of it, which specify the network interface and static IP address range you'll be using. If you choose to use something other than 777, just make sure you're consistent across the rest of the files as you move along. Restart this service, rename this file, and replace it with a new one containing these 3 lines, which again specify the wireless network interface and the IP address range, and this last line specifies that all domain name requests get redirected to the IP address that the Apache server will be on. Save that and then create this file containing these lines. This is the network interface and this will be its name. If you choose to use something else, just make sure you use legal characters, otherwise it won't start. Open this file and point to the one you just wrote by uncommenting this line and add the file name to it. Third is the web server. Change the ownership of this directory, delete this file, then move the Dropbox files into it. I used SCP like this. You could alternatively copy them over a flash drive or move them directly onto the micro SD from your computer, or get creative and find another way as long as these files end up in this directory. Next, make these 2 directories and modify the permissions to 777, which is necessary to allow uploads. Then open this file, comment out these 2 lines, and add this block to the bottom. And then open up the Apache configuration file, change this block to look like this, and add these to the bottom. These 2 prevent PHP script execution in the 2 upload directories, and this replaces the index.html page that was deleted earlier with the Dropbox page. Then create this file containing this block, which password protects the control panel, and run this command to create the password. Use a different one that you use to reset the default password in the beginning. Fourth is a database. Use this command to enter the database. There's no password yet, just hit enter. Then use this command to create the password. If you use something different than what I did, which you should, you also need to change the password in the PHP scripts to match, which I'll show you how to do after. Then use this command to require a password to connect to the database. Create the database, create the 2 tables, and then quit. Fifth is PHP. First, if you use a different password for the MySQL server, these are the 2 lines you need to fix. While I'm here, this starts the user session, which in this version only stores their chat name. This is used by the function below for determining which file symbol to use for the download button for the shared files. This prints all the shared files, and in the control panel also prints a delete button next to each. This uploads the submitted files. This is for the sign button, and all this is processing chat commands and message and signature uploads. The rest is mostly just the page's structure. Next, open this file, navigate to this line. In Nano you can use Control W, then change it to whatever you want the shared file size limit to be. I use this because that's enough. If that doesn't work, you need to verify that PHP is using that file. So create a document like this in this directory which creates this page and check. If it's using a different php.ini file, change that one instead. Sixth is the LED. The alert.py script uses pin 2 for red and pin 4 for blue. I actually didn't skip 3. It's green, which is cut from the final script but can be added back with like 2 lines of code. Use either of these for the common, which are the 3 volt pins, and open this file and add this line to the bottom to allow Apache's user to execute the script. If you weren't including the RGB LED, don't do that and delete this line from the Dropbox.php file. These lines in the script determine how long the glowing and fading processes take, so you can modify them to suit you. You can also really easily switch which pins are connected to change which colors glow. And you can add more yourself just by adding these function calls, or make your own. These blocks make it so that rather than just turning on or off, the LEDs flicker so fast that they appear to be glowing and then fading out, something apparently difficult to capture on the camera because of their frame rate and shutter speed, so just take my word for it. I used PCB like this. I started to together cut the PCB and use female to female jumping pins, which are cut in half to connect the pins to the board. If you do it like this, just make sure you cover all the conductive material that chances coming into contact with another part of the board. A little bit of masking tape on the bottom of it should be enough, or find a way to keep it separate from the rest of the board. And that's it. Reboot, there's some processes that need to be restarted, then unplug it from the router and test it out. Go through this checklist. If anything isn't working, you'll need to do some troubleshooting. Good luck with that. Some of the code, like the filebox iteration, the way it's set up, and the alert script, kind of exposes the fact that this whole project is actually based off of another, one that I'm still working on, but it's going to be a while before it's finished, so I decided to put this together before I switch focus elsewhere for the time being. What I'm saying is this isn't the final version. I'll make an updated version eventually and show the full project that I've been working on once that's finished as well. It's just that every time I finish implementing some feature, I tack like 6 more into the end goal. I need to give myself more time to work on it, which means I have to take care of some other things first and come back to it when I have the opportunity to do it right. So this isn't the full product. It's more like a sample. And if it's well received, I'll keep putting in the effort to make the projects that I make for myself like this accessible to others through GitHub and these tutorials. I took like 2 breaths of narration. I'm about to pass out. Peace.